Hello, everyone. Thanks and welcome to my final presentation of IS 597 BS class. I'm Zhou Sang, and my project is King Othello. It's a variation of Othello with king pieces added. The first slide I will introduce is Othello. And the first thing I want to mention is the difference between Othello and Reversi. Actually, I got this misnomer in my project proposal stage where I misnamed Othello for Reversi. Reversi is actually an ancient game invented in the 18th century, while Othello is the modern variation we play today. So I got this wrong name from the Windows XP system since 2008, where I first played it. Its rules are really easy, but very exciting, I would say, because I even found some resemblance between the election and the trio of Othello. For example, if on the election day, on the earlier stage where we can see Trump is far ahead Biden in number because these states right has big advantage. So if we turn our right into Trump's vote, it will become this number. But actually, the result is really appalling as Biden got reversed, take control of the situation after several days. So the final game is really different from the beginning game. And this actually happens a lot in the game of Reversi, where we can see an example if this is a case where only one white piece is here and all surrounded by the black piece. So will the black win? If in fact, black cannot win because black has no moves made. Well, the white has 4 moves. And after taking this 4 steps one by one, we find the white just reverse the black and with a big win. So it's kind of really interesting to know because it won't until the last moment you can know who is winning and who is lose. So it has the thrill of changing suddenly. And this is one reason I like the game. This time, I'm going to introduce my original variation of Othello because I find the checkers and chess, they all have king pieces that have more power. So I thought, why not put a king in Othello? With this idea in mind, I gave a rather simple rules that a king can only be flipped when directly sandwiched by two opponent's kings. So as we can see in this case, if a white king is here and they has several black pieces and the black king here, then if white has a king, it can place here. So all these black pieces between got sandwiched by the two white kings will all be reversed to normal pieces. But on second case, there is a common piece here, and say if we want to put a white king here, I set the rules to say that it cannot reverse these pieces. So it's not a valid move for a white king to place here. I did this for 2 reasons. The number one is that to be consistent with the Othello game's rule, because Othello always check the nearest opponent pieces, and the white, this is not the nearest opponent piece. So by conforming to the nearest principle, we said this cannot be a legal move. The second reason is you want to prevent giving the king too much power, as it may break the balance, because it might become too powerful if it can be remotely connected. If there is several white pieces here, it can still have the power to reverse kings, then the advantage of the king is too big. So with all these considerations, I said they must be directly sandwiched by opponent's kings to reverse the king. With this variation, we find the king is very powerful. First, it can serve as a protection or fortification of existing pieces. Because it is immune to simple attacks, because the opponent must use a king to remove this threat. Also, it can be a silver lining when you are forced to step into the danger zone. The danger zone refers to those spots adjacent to the corner or borders, where if you take those pieces, the opponent might take the corner. This feature added, it adds more fun and more flexibility to the game. The third one is, fundamentally speaking, a king is essentially a border or corner out of thin air, and it can just be deployed artfully and skillfully. And I think this adds some spice to the game. Although the king is very powerful, but I do not think it will break the balance for three reasons. The first one is that the kings are both useful in early and late games, and there is no saying I put the king first, my advantage is bigger. The king can be useful in any time of the game. And second, I set the rules to restrict his power, as mentioned here. This is a restriction of his power. Third one is that I can still win my AI with 0 king pieces. So if without king piece, you can still win. It's just not that powerful to break the balance. So this is an introduction of how to play the game. You first need to run this GUI underscore king.py, and you will automatically be the black piece where you click on screen. If you use left click, it means to place a normal piece, right click to place a king piece, and each player has 5 king pieces. And the AI is default is a min-max based, and default the search depth is 1, and you can change this manually in the program. But the GUI is not that complex to have a lot of functionalities, because I think PyQt5 is really too complicated for me, and it can take a lot of time to. Next, I will give an overview of my project files. Othello.py is the game logic for normal Othello. It includes functions like human vs AI and AI versus AI. You can choose what strategy and AI use and compare to see what's their performance. GUI normal is the GUI program for normal Othello here. It's basically a draft for the file here, where GUI king is our main file, and King Othello.py is subclass of Othello.py. So we can see this one evolves to here, and this one evolves to here. And minimax.py has included some minimax functions and evaluation functions, and it's basically about minimax programs as well as some settings. So next, I will briefly introduce my project timeline. I actually started working on this project on October 28th, where I created my own chessboard in Photoshop. As you can see here, I self-made. I draw those lines and draw those dots. But the image of chess is I take from other Othello programs. Actually, it's from an iPad program. And I added this king icons myself on October 31st. And I started a Gomoku AI project. It used the PyQt5. So I learned some GUI features there. And on November the 4th, I finished the logic part of Common Othello. The November 9th, I finished, I got the simple GUI working for human vs random move AI. On November 10th, I focused on the minimax algorithm and finished it. On November 17th, I did the rules for King Othello. On November 22nd, I implement the GUI for minimax King Othello. So this is final version we got. Play as black, and the computer, the minimax AI plays as white. So let's come to the game logic. So for command line Othello, the game logic is really simple. It can be described in this few lines of code. We use a while loop. While is the game not end, we just find if there is valid moves for a player. If it has a move, it will get the move from the player, whether you can assign the black player as computer or white player as yourself, or you can set different AIs. So if move is valid, just take move. After taking move, switch the turn. If no valid moves, just switch turn back to your opponent. You can add settings like mode equals man versus AI, human first equals true, and black strategy is min-max, white strategy is random, or etc. It's very simple in the command line Othello, but the GUI is quite harder. But we will not spend time on there because it's maybe not relevant to most people's needs. Next thing I will talk about is the minimax and the evaluation functions. I will just give a short review of alpha, beta, minimax. So minimax, in my understanding, is try to iteratively compute and return an equilibrium score. Suppose two players are always intelligent and always choose the optimal moves for their own interest. The alpha beta is a pruning can prevent exploring unnecessary steps. Steps for implementing the alpha beta minimax is first define an evaluation function to get the score. We use minimax to calculate the score based on the different depths. With this tool implemented, we can find a evaluation dictionary where it has move as its key and the score as its values. At last, a player always choose the move with the best score as the optimal solution. My algorithm implementation was mainly from Sebastian Lack's YouTube video. Next, I will talk about the evaluation function. I mainly used 3 evaluation functions and tested their performance. The first one is called positional score sum. It's the sum of all the positional score. So what is the positional score? There is a blog I referred to where it assigned different scores to different regions on the board of an Othello. Because we can see the yellow, the corner are the best parts because they can never be flipped once they are taken. So this have high scores. And this red zone is what I call the danger zone, because when you put a piece here, your enemy will be easy to take the corner. So there are generally bad moves to be taken at. And this is just the common area. This one is good, and this one is not that good because, again, the border is good, but this one makes your opponent gets easier access to the border of different position score. You can assign, for example, here at 100, here at minus 100 or something. Second idea is to use mobility, because we can see in this mode, although the black taken the much of the screen, it really has higher positional score in this function, but the white actually has 4 mobility, because the white can move here, 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 but the black has nowhere to move. So in the mobility function, the white wins. So this function can better describe the real situation going on in this picture. The third function is post-mobi. It is defined as the first one plus the second one. So I think the combination of these two will compensate the shortness of each other and bring a stronger comprehensive solution. So with all these 3 functions, we abbreviated them as the first one as PS, then second one as MO, and third one as PSMO. Also, I want to say all these 3 functions are defined as the sum of black scores minus the sum of white scores, because in minimax there is the maximizing player, which is black, and the minimizing player, which is white. So we said the black is always the positive one and the white is always the negative one. We use a single score evaluation for black and white. In this slide, we are going to see a composition among different evaluation functions for AIs. All these AIs except the random one are all based on the minimax, and their only difference is the evaluation function we choose. As we previously introduced, there are 3 kinds of evaluation functions: the PS and IMO, and positional score plus mobility. And the number here after the underscore is the search depth of the minimax algorithm. These 3 are depth 1, depth 2, and depth 3. This table shows what's the win rate of black when competed against a white AI on this row. So as we can see, a random black AI versus a random white AI win rate is 50%. But when the minimax with depth 3, win rate is 80%. So this table can actually tell us a lot of things. For example, we can see AI Sung has really crushed the black AI with only less than 10% of win rate. So generally, the higher the depth, the stronger the AI is, and the most strongest AI are both from depth 3, whereas positional score sum and positional score sum plus the mobility, their difference is not that much big. So finally, we find that these 2 evaluation functions are rather similar. So we just stick to the positional sum score as this final evaluation function for the King Othello. So in this slide, we will talk about our thinkings on the modification in the evaluation function for King Othello. And the first observation is that king pieces can serve as an extra protection for adjacent self piece. For example, we can see in this graph, when the black king placed here, the adjacent black pieces in this line and this line, they are less vulnerable to white's attack. So we think we want to encourage this to protect as many its own pieces as possible. So we added additional score, the piece value positional score of this one, this one, this one, this one, and all the ones that protect again to encourage this protection behavior. The second observation is that kings are limited and AI might need saving its king pieces to place it where it truly matters. So in this observation, set the AI to choose one best move from the common move set and one best move from the king move set. Then we compare these two representatives and only choose king move when their gap has exceeded a certain threshold. The third observation is that we want to avoid our own king being captured by the opponent, but on the other hand, we want to try to capture opponent's king. To encourage this kind of behavior, we define a penalty score where if put adjacent to a king or at the end of line of a king, where it can easily be turned by opponent's move, we add a penalty score. On the other hand, if the king is placed on an advantageous position, like on the border, it might secure the border, so we add a different bonus score. So with this idea of penalty and bonus score, we teach the AI to try to avoid or to incentivize about such kind of behaviors. There is more creative change to be added, but as time limit, my share of modification in the King Othello's evaluation function will just stop here. The last is a summary. In conclusion, to comment on my own AI is better than many of AI I played with because it is extremely reluctant to go to the danger zones, and this makes it less prone to make mistakes. But when talking about my own AI for King Othello, I think it currently is not smart enough, perhaps because I currently do not know what's the best strategy for the King Othello too. So there is still room to improve. Next, I want to thanks to Mr. Weibo for giving us a wonderful course. I really learned a lot of new games, and the knowledge behind it is more interesting. I now feel myself more confident in programming, and it's really one of the best courses and one of the courses I learned most in high school. So next we will talk about the lessons learned. For the GUI part, we might always try to separate the game logic from the GUI. And in testing phase, we might test the complete logic game first and never directly go to GUI part to try to save some time, because the GUI will not tell you where the bug is and just terminate out of blank, leaving you no idea of where to fix it. So always game logic first and then GUI. So in summary of project, there is 970 lines of code in my project. It's the longest project I've ever written. And also it's my first time to set foot in GUI and game AI, and I think it's really good experience. It's also my first independent app, although it's pretty simple. So all in all, it's great experience in thinking and coding, and I think that's a very good start for the future journey. So thanks everyone for your patient watching, and happy Thanksgiving. Thank you. Hi everyone, this is a demonstration of how to run the program in PyCharm. So we first find this program, GUI king.py, and in here we run the program, and it will automatically gives a GUI, and these are the possible moves you can take. And the first one, let's say we take here, and right place the king. And I will also try to place a king by using right click here. And this is a game we try to demonstrate. I will just randomly make moves. And yeah, this is just the game. And after just click randomly, randomly clicking, I will place a king here, place a king here, and I win. This is as simple as this. So thanks.